Welcome all of you. In this video series you are going to learn about monostable experimental setup and a waveform you will going to see. So this is the connections, okay, as per the circuit diagrams. So this is as per the circuit diagram of that monostable multivibrator. When you have see that one unstable multivibrator, how it is different. Unstable multivibrator means you are used two resistance you are used, but here is a only one resistance area only used. Here is a unstable multivibrator, you are not applied any function generator input, but here is a monostable. Okay, here you will going to apply that one pin number 2, you will going to apply the trigger pulse. So trigger pulse is a square wave we will going to use for the triggering. So once you will going to give this triggering, okay, the output of that one as usual of unstable, so square wave form is produced in that way 3 with respect to ground. So you have see this is a unstable, so this is unstable, you have seen about the previous of the video. So here is there are two resistance 1, resistance 2, okay, another one is a pin number 2 and pin number 6. Pin number 2 you are not apply for that any trigger externally, you are not using any trigger externally. So you pin number 2 and pin number 6 was short circuited. Okay, what is output? Square waveform. If you want to see the capacitance, this capacitance across, you want to see that one CRO, so plus with respect to the minus you have see charging and discharging. So here is what about that one, here is a pin number 2. So pin number 2 is a, you will going to trigger, so triggering with the help of that one, okay, function generator, okay, square waveform you will going to trigger. That is a point number 1. Function generator, it is used for the triggering. Output you will going to see as usual 3 with respect to ground. So you will going to square wave is a triggering purpose, you are going to use the triggering. So what is output? It will going to produce the square waveform on time, off time. If I have see that one on time during the time of the capacitance occurs, so this capacitor occurs I want to measure. So on time period it is a charging, off time period it is a straight line to discharge. So on time and then off time. If I have see that once, okay, so output voltage I will going to hold the waveform. So you have see on time, okay, on time square waveform. So during the time it is a charging and immediately on time is over, it is straight line to discharge. So this is about that waveform. Okay, so this is a output waveform and with respect to the capacitor voltage, capacitor across the point. Output pin number 3 with respect to the ground, this is a capacitor pin of that one 6 with respect to ground. So here you have see that one setup. So here is a function generator. So function generator, it is a square waveform, you will going to give that one triggering you will going to give. So frequency you are going to set about the frequency. In hertz you have set about the frequency, hertz 100 hertz you are going to setting. So variations, let's we will going to see as per the circuit diagram connection is made. So let's see I will going to vary. So you can see that one on time. So during the on time period, see that one closely. So on time, so this is on time. During the on time, it's a capacitor, it is get the charge. So during the off time period, immediately the capacitor is getting the discharge. It's going on that one. Due to that one off period, it's get the discharge. So it's a capacitance across the voltage of the channel. So this is output of the channels. So capacitor charging and then once the off period get the discharge. Okay, you can see the circuit connections. So this is circuit connections. Okay. So this is a Monostable multivibrator, okay, online simulations. So it is provided by IIT virtual laboratory. So here you have the option, you have see that once, okay, monostable. So in that one you will going to give that one. So here is a fixed resistance, even you will going to vary the 10 kilo ohm. As per the laboratory I am also used to this 10 kilo ohm. So on time, so triggering you will going to give, so you will going to give the off time only. Here you will going to give the off time. So total time is I have set it as 100, okay, I have give the 20. So if I going to give the 20, so what based on that one your result on time, and then on time, and then T out, another one is a V out. So it will going to come, see that one I gave for that one 20. So 20 is okay, 20 is off period, so remaining 80 is on period. So remaining 80 is an on period. So okay, this is a 20 with respect to that one I gave. Okay, if I will going to give, okay, start about that one. What about that output waveform? Okay, this your output waveform is produced. So output of that one is what about that one maximum voltage? So from 0 to it's a 12 volt, maximum of the voltage is a 12 voltage. What is on period? 100 milliseconds. On period is 100 millisecond, and off period is about that one. Okay, so it's a 11 okay, so off period is a 11 milliseconds. So this is the output of the waveform, and with respect to the input waveform, okay, in milliseconds, V out in time, V in time. So V in time and V out in time. So I will going to change. So for example, I will going to 20 instead of I will going to change into the 50. So to 50 I got changed. Okay, if I will going to change instead of 50 in off time means on time also 50. So okay, here is a please keep that T of is less than 0.25 into time periods. So as per the formula we will going to use